then in future years, they just don't get recordings when I screw up. Sucks to suck. The function horizontally reflects. No, we're just gonna say reflects about the y-axis. Remember how we use that terminology for stretching, right? We would say it vertically stretched or horizontally stretched about the y-axis or about the x-axis, depending on the question. We're using that terminology again here. So I reflected about the y-axis. It means I flipped around the y-axis. Notice that it's the x values that changed, though, right? I reflected over there. That means my x values changed. My y values did not change. They stayed the same. 5, 9 became -5, 9. Y value did not change. Yeah.
If you had a stretch and a reflection, would you do like one of them before the other one, or would it be different?
Yeah, it will make a difference. I think we get there today. You need to stretch first. Yeah. Sketch the graph of the transform function. We already did. We sketched it. State the coordinates of any invariant points. The invariant point is at 0, 4. Notice it's on the y-axis. If I reflect about the y-axis and I'm on the y-axis, then I can't reflect, right? Cool. Let's do a horizontal one. So to describe vertical reflection, so the other direction, they're going to give you the same equation, y equals x minus 2 squared. Now they've moved the negative. So notice that the negative is now in front of the function. So let's write what that looks like. They're saying take your original function and put a negative in front of it. My original function was y equals x minus 2 squared. I need to put a negative in front of it. That's what it would look like. Awesome. Let's graph it. So if you were to graph this thing, feel free, like you could pop in your calculator, right? So you would change this to be negative x minus 2 squared. You graph that. It looks like this. You could get your table of values, right? So you could go second graph, and you could see your table of values if you wanted to find some points to graph. That's how I would go about my business. So my points that I'm going to have here. Oh, I was like, that doesn't match up. No, it does match up. That's right. I have a -1, -9, so point down here. I have 0, -4. I have 1, -1, which is actually not on my graph. That's okay. I have 2, 0. I have 3, -1. I have 4, -4. And I have 5, -9. I have this looking quadratic now. Again, the more points that you plot, the better your graphs will look, especially when it comes to quadratics and stuff like that, because it's hard to draw a good-looking quadratic. So more reference points, the better, right? Like connect the dots. This one's more visually almost appealing. Like it's easier to see what's happened. If you look, that graph has very clearly flipped downwards. Right? It's the same thing, but upside down. What happened was it reflected down here to the other side of the x-axis. Okay, so describe the transformation of the original image. I'd say the function reflected about the x-axis. It flipped to the other side. Oh, that was rough for the computer. It flipped to the other side of that axis right there. Fold it over it.
Are we always going to be reflecting above the axis, or
there will be one other place that we reflect, but for the most part,
be like y equals 4?
no. You could, like, it is possible that could happen. We're not going to see it, but like in future math classes, you could reflect over anything, right? But we won't see much of that. We'll see reflection about x-axis, y-axis, and then something called the xy equation, which you'll see. Yeah.
Are there going to be questions where they're like you're reflected here, translated here, and stretched here?
Oh yeah. So, and that's what we're building up towards, right? So our last lesson, Tuesday next week, that's what we're going to start doing. So it'll be you have a graph, you stretch, you reflect, you translate, and you're going to move completely to a whole new spot.
Is that always you already do? You stretch, reflect?
Always. And it's the reason why will be because of bed mass. Okay, you guys good back there? Yeah? Okay, sketch the graph. We already sketched the graph. State the coordinates of any invariant points. Logically speaking, if I reflected about the x-axis, where should my invariant point be? On the x-axis. If you look, sure enough, that's where it is. It's on the x-axis. That point did not change. That's my invariant point. Right here, it's at 2, 0. I'm just going to, again, put a little note. It's on the x-axis. I do want to make one more note of what's happened here. Like visually, obviously, it reflected. Mathematically, what I just did was I took points, like this one up here. That point was at -1, -9. Sorry, -1, +9. My computer is struggling. -1, +9. There we go. And what I did was I multiplied the y value by -1. Right? I changed the y value to be negative. That's what caused this visual reflection. It now moved down here to -1, -9. Essentially, like a reflection is also just a stretch, right? Like same idea. I multiplied by a factor of -1, which is why it flipped to the bottom like that. Awesome. Let's do some more questions. So we got this guy. A partial graph of y equals f of x is shown below. I find that what sometimes people get caught up on is they don't know what the equation is. You don't know what this equation is. They just called it f of x. Okay, so this thing right here is f of x. Hello, Mr. Cross. How are you? Just live stream my class. They talked about that for sure. I'm going to go back to teaching because that's what I'm supposed to do. Okay. Don't get caught up in like what's the function, because they're not going to tell you the function, right? And like just go with the picture of it. This is the function. Don't try to figure it out at this point. It's too hard. It says all of the x-intercepts of f are shown below, and all the x-intercepts are integers. That just means they are what they actually look like. Like this one right here is actually at -2. It's not -1.9 or something like that. This one is at -1. This one is at 3. Okay, they're just trying to like help you be like, yes, that what you see is actually true. Okay, if g of x, so a new function, equals -f of x, then the largest x-intercept of the graph of function g is. Okay, let's try to sketch g of x. Okay. Yeah.
I don't know if I should be doing this for it, but considering it's a vertical like transformation, wouldn't everything just all the x-intercepts still stay the same?
Yeah. Yeah, you're gonna be good. We're still gonna sketch it though, because I want to make sure that we got that down. So you're gonna sketch g of x. They said that g of x was equal to the negative f of x. This is like your a value, right? When the a value was negative, it was reflecting about the x-axis. That means your picture should flip about that line right there, the x-axis. Everything above should flip below, everything below should flip above. To sketch it, just try to take some points and kind of like put them where they go, right? Like this one down here. Oh, no, not the line, the color, please. This one down here is approximately negative 3, 9, negative 9. So it would reflect to go way up here at negative 3, positive 9. Right? Like that's what's happening. It's flipping to the other side of the x-axis. The y values are all being multiplied by negative 1. I would go and try to find a few points and do that. This is on the x-axis, so it's not going to move. This one up here would move slightly down to the other side, so like to that spot. Let me do it in a different color so it stands out. This blue one would go down here. Right? It's flipping to the other side of the x-axis. TV's frozen? That's good. And blurry. A point. Right? So this point would flip to here. Pick another point. Like this y-intercept, which is about negative 4, would flip up to about positive 4. This minimum down here, which I think is at 2, it's about 1.5, 2, would flip way up here. Right? This x-intercept would stay the same. Because on the axis, it can't go anywhere. And then something up here would flip way down here. You should get a graph. I'm not going to be able to sketch it for you. I'm going to draw it, and then I'm going to see if I can get the cast. It should look something like this. Go down, up. I actually wouldn't have arrows on the end, but I can't erase that arrow without erasing it all. Okay, so those of you who are watching the video, you can actually see what I'm doing. Lucky Erica. But now the video's done, so you're done.